Alright, this video has the solutions for the 8-2 multiple choice practice. And I have the answers marked already, so if you got the answers right, you can skip through, I guess. Alright, the first problem here, we have if the antiderivative of x squared cosine x dx is equal to this, then f of x is. Well, this looks a lot like the our little recipe for integration by parts. This looks like the integral of u dv is equal to uv minus the integral of v du. The reason why I'm recognizing this now is it's not actually to a final answer here. They're just looking for this piece of it. So I know we could do this one by doing tabular integration. It's exactly the right type, but I think we want to set it up like this so we can figure out what the f of x is. So let's see. If I make u equal, in case you're confused about what the u and the dv should be, we could just maybe refresh our memory. We could use this, remember our liate or liate, or however you want to say that. So whatever comes first here, we should make the u, and what comes second, we should make the dv. So here, our algebraic function is the x squared, and trig is the cosine x. So we'll make this the u, and this the dv. So u is equal to x squared, means du would be 2x dx. dv would be cosine x dx, and the antiderivative of that would be sine x. So rewriting would be uv would be x squared sine x minus the integral of v du, that would be 2x sine x dx. And there you can see there's our f of x. So that would be x squared sine x. And eventually when we evaluate this, there would be a plus c, so they put the plus c in here. But there's our x squared sine x. The next one, same thing. They just didn't finish this problem. So although this is in your notes, we can just go through it again and do u would be sine inverse x, and du would be 1 over the square root of 1 minus x squared dx. And the dx, or sorry, the dv would just be dx. And remember, that's like an algebraic function. It's like the algebraic function 1. The antiderivative of 1 is x. So using our recipe again, that gives us uv, that's x, sine inverse x, minus the integral of v du, which would be x over the square root of 1 minus x squared dx. And that's as far as they took it here. How would we finish this? Remember, we did a u substitution on this. We let u equal to 2x, or sorry, u is equal to 1 minus x squared, and we went from there. Okay? Next one, we've got a definite integral, and this looks like a perfect candidate for tabular integration. So, like my x and my e to the negative x. Take the derivatives of this, antiderivatives of this. They change signs because of the negative in here, and we do our little tic-tac-toe game with those. So my antiderivative is negative x e to the negative x, that's this one, minus e to the negative x. That's the antiderivative of this. And we want to go from 0 to 1. And plugging those numbers in, let's see what we get. We get, plugging 1 in, I get negative e to the negative 1 minus e to the negative -1 minus, plugging 0 into this, well, 0 times something is 0, minus e to the 0. So I've got two of these. That's minus 2e to the minus 1 minus e to the 0 is 1, and that matches up to c. Next one, this is similar. Let's see. Yeah, this is similar to the first problem. This looks a lot like our u dv kind of function here. So let's set it up like this and see what happens. I'm going to go ahead and do this on a separate piece of paper so we have room here. So if u is equal to f of x, then du would be f prime of x, then dv would be the sine x, and the antiderivative of that is negative cosine x dx. So rewriting that, I get uv, which would be negative f of x cosine x, and notice that that matches up to this, minus the integral of v du. There's another negative sign here, so that'll switch the sign of that, and f prime of x times cosine x dx. Right? And then notice that this matches up to the 3x squared, and they want to know what f of x is. Well, if this is f prime of x, then f of x would be the antiderivative of that, which would be x cubed. Next one, this is another one that's all set up to do tabular integration. Now, cosine x, the antiderivative of that is positive sine x. Be real careful with your signs here. And then the antiderivative of that is minus cosine x. And we switch signs like that. So my antiderivative is x sine x plus cosine x from 0 to pi over 2. Plugging the pi over 2 in, I get pi over 2 times the sine of pi over 2 is 1, plus the cosine of pi over 2 is 0, minus, plugging 0 in here, 0 times anything is 0, the cosine of 0 is 1. And that's pi over 2 minus 1, which is e. And last one, another tabular integration. Antiderivative of e to the 2x is 1/2 e to the 2x, and the antiderivative of that is 1/4 e to the 2x, because every time we take the antiderivative, we have to divide by 2. Signs switch. So my antiderivative is 1/2 x e to the 2x minus 1/4 e to the 2x plus c. And that's answer choice A. And maybe we'll keep going. Maybe we'll put the step-by-step ones in here too. Let's see if we can get them in here. We'll try to go fast. Okay, the derivative of a function is given by this, and f of 1 is equal to 0. Anytime you're given a derivative and an initial point, makes us think that at some point we're going to have to solve for the plus c when we take the antiderivative. Okay, this function has a critical point at 1. Does it have a relative minimum, maximum, or neither there? Well, let's set up our number line. They already told us that it has a critical point at 1. Of course, we could have figured that out. We know that natural log of x is 1, so let's try points on either side of this. The x squared here, I'm plugging points into x squared natural log x because this is the derivative. That's always going to be positive, so it's just a question of what happens here with the natural log function. And if you think about what it looks like, the natural log function looks like this. It goes from negative to positive. So if it's going negative to positive, that means it's decreasing and then increasing, so this is a minimum. And my little sign chart is the justification. On what intervals is the graph both decreasing and concave up? Well, if we want concavity, we have to figure out the second derivative. So let's see. Second derivative would be the derivative of the first times the second plus the first times the derivative of the second, setting that equal to 0 and factoring out an x gives me x times 2 natural log x plus 1. Now, the zeros of this are 0, but notice that since there's a natural log in this, we don't have any domain down below 0 anyway, so although that is a 0, it doesn't really matter for us because that's the end of the domain of the function right there. And I know from the first part that for the derivative, that's the critical point, and it goes from minus to plus. Now on the bottom of this same one, just like we're doing acceleration and velocity, trying to figure out speeding up and slowing down, on the bottom of this chart I'll put where the zeros of this are. So setting this part equal to 0, I get x is equal to e to the negative 1/2. And thinking about that a little bit, e is kind of close to 3. So 3, the square root of 3 is about like, oh, I don't know, somewhere like vaguely around 2. It's like 1.7 or something. So then the negative would flip it over. So that's going to be like 1 over 1.7 or 1/2-ish, something like that. So it's down here anyway, e to the negative 1/2. And this, although it's been shifted around a little bit, it's really just another version of this. It's a natural log function. This shifts it up 1, and this gives it a vertical stretch. So it still goes from negative to positive. And again, the x here, since I'm only in positive numbers, that doesn't change the sign. So where is it decreasing and concave up? Well, that would be this interval right here, in between e to the negative 1/2 and 1. Find f of e. Well, let's see. If we want to find f of e, I think we need to find the antiderivative. So there's a couple ways to do that. I'm just going to go ahead and find the antiderivative and then solve for c. This is an integration by parts problem. We're going to let, using our what comes first logarithmic function, so that should be the u. And dv should be the x squared dx. The antiderivative of that is x cubed over 3. So rewriting that, we get that the original integral turns into uv, which is x squared over 3, minus the integral of, uv, which is x cubed times natural log x. Sorry about that. That's uv, right? Minus v du. That's where the x squared over 3 is. And the antiderivative of that x cubed over 9 plus c. Now, our original point that they gave us is the point 1, 0. So, plugging 1 into this, I get 1/3 times the natural log of 1 minus 1/9 plus c is equal to 0. So plugging in the 1, getting 0. Well, natural log of 1 is 0. So that looks like c is going to be 1/9. And that means my original function, f of x, is x cubed over 3 times the natural log of x minus x cubed over 9 plus 1/9. And they want to know what's f of e. And plugging e into that and simplifying, I'm going to go ahead and look at what I have here. It's you should get 2e cubed over 9 plus 1/9. Okay, and then part D, they want what's the limit as x approaches 0 of this function? What's the derivative? X approaches 0 from the positive side. It's got to be from the positive side because of the natural log function. X squared, natural log x. Well, you might plug in the 0, and that gives us 0 times the natural log of 0 is like negative infinity. 0 times any form of infinity is an indeterminate form. And besides that, anytime you're doing limits in BC calculus, probably L'Hopital's rule is involved. So we need to turn this into a L'Hopitalable form. And we do that by moving the x squared to the bottom as a negative. And that gives me an infinity over infinity when I plug the 0 in. So now I can take the derivative of the top and the bottom. Off the screen there. And let's see, the derivative of natural log x is 1 over x. The derivative of x to the negative 2 is negative 2x to the negative 1. No, it's not. Negative 2x to the negative 3. Sorry about that. Drop the exponent 1. Right? And x to the negative 3 on the bottom is the same as x cubed on the top, right? In the same way we got that to the bottom, I'm going to move it up to the top now. As x approaches 0, 1 over x times x cubed over negative 2, which is negative x squared over 2. And when I plug the 0 into that, it's not a problem anymore. It's 0. So we did have to use L'Hopital's rule for that. Okay, next step by step. Derivative of a function is given this and an initial condition similar to the last one. Find any critical values of f and determine whether f has a relative minimum, maximum, or neither at this value of x. And notice that the domain is only greater than 0. So anything less than 0 we can ignore. All right, so critical values, that's where the derivative is equal to 0. So, well, that can't be 0, so it's got to come from this, which factors into x minus 3, x plus 1. And that gives me x is equal to 3, or negative 1. And since the domain is just greater than 0, we can throw that one out. So we're looking at what happens at 3. And if you check the signs here, you should find that it's negative and then positive when you plug those in here. That's always going to be positive, right? So you're really just checking here. And that means that at x equals 3, we have decreasing then increasing, we have a minimum. Right? Our justification is our sign chart. On what intervals is the graph both decreasing and concave up? Well, we've got the we've got that part of it from part A. This is what the derivative's doing. Now let's find what the second derivative's doing. The second derivative would be the derivative of the first times the second plus the first times the derivative of the second. And factoring an e to the x out and putting those together, I get x squared, the 2x minus 2x cancel out, minus 5 times e to the x, and that gives me x is equal to plus or minus the square root of 5. But I can throw out the negative one because my domain's only positive numbers. Square root of 5, that's in between 2 and 3, right? The square root of 4 is 2, square root of 9 is 3, so somewhere between 2 and 3. That's here, square root of 5. And if you test numbers in here, like a 1, for example, you'll find that it goes from negative to, try a number like 3, to positive. That's what the second derivative does. So if we want decreasing and concave up, decreasing and concave up, that would be in between the square root of 5 and 3. And last, similar to what we did last time, we want f of 4. So if we want the f function, we're going to have to find the antiderivative of this. And that looks like tabular integration. So I've got x squared minus 2x minus 3. Derivative of that is 2x minus 2. Derivative of that is 2. And we've got e to the x, antiderivative, antiderivative. Signs change like that. So my antiderivative is x squared minus 2x minus 3 times e to the x minus 2x minus 2 times e to the x plus c. Right? Now they gave us a point, the point 1 comma e, so I can plug that in and solve for c. So plugging 1 in, I get 1 minus 2 minus 3 times e to the 1 minus 2 times 1 minus 2 e to the 1 plus c is equal to e. This gives me 1 minus 2, that's negative 4e, that's 0, plus c is equal to e, so c is equal to 5e. So my original function, the antiderivative of this, after we solved for c, is x squared minus 2x minus 3 times e to the x minus 2x minus 2 times e to the x plus 5e. And they want us to find f of 4. So plugging 4 in here, that's 16 minus 8 is 8 minus 3 is 5. E to the 4th minus, plugging 4 in here, that gives me 8 minus 2 is 6. E to the 4th plus 5e. And that is minus e to the 4th plus 5e. And let's check and make sure. Oh my goodness. You know what I did? I forgot when I did my, sorry, I'm just checking this against, I didn't go all the way down to 0 here, so we missed a term. Maybe you caught that. But there's a 2e to the x here too, plus 2e to the x. That would have given me here, let's see if we can fix this up. That would give me 2e to the 1, and that would mean that I would have minus, let's mix that up. That would give me another 2e here. So would that make that 3e instead of... Yes, it would. So the plus 2e here, that would make this 3e instead. You can go back and check that work. And so that's going to be 3e, and then I missed that term here, the 2e to the x. When I plug 4 into that, I'm just going to stick that on the end. That's plus 2e to the 4th. So adding another 2e to the 4th is going to make that positive. And then my c there, that's 3e. So sorry about that. But that, yeah, I did this one before, and that's the same thing that I got before. I didn't make that mistake, so sorry about that mess. But e to the 4th plus 3e, that's the correct answer.